Today we will simplify radicals with fractions. I chose 3 examples to help you with Algebra 1 EE3. So first example here, we have 2 perfect squares. It's still a fraction, but they're both perfect squares. So if you are to take the square root of 9, it's a perfect square. So you get 3. You take the square root of 4, you get 2. There's nothing you can do to simplify that fraction. So this is your final answer. Another way you could have done that is you can just, in this case, to simply put the question in the calculator and then you will end up with that. But sometimes it's just faster if you know your perfect squares, just to take the square root and try to simplify the fraction there. If you're not sure how to put in the fraction bar, you're going to do alpha, you're going to do y equals, and then you push enter. That's how you get that fraction bar right there on the calculator on the main screen. On number 2, I'll always try to simplify the fraction first to see if that can help me. So if I simplify 10 and 18, I can bring it down to 5/9. So they're both under one root. So the calculator did the work for me. Now I'm going to split that in 2 radicals. So square root of 5 over square root of 9. Because at this point, as soon as I saw square root of 9 right there, I know square root of 9 is a perfect square. And I can easily take the square root of 9 and get 3. Square root of 5, I can't simplify, so you can just leave it alone. There's nothing you can do about square root of 5. And since it's in the numerator, you're good to go. That's it, done. Number 3, we're going to have more work to do on number 3, but it's still not bad, we can do it. So we're going to try to start out by simplifying the fraction. So 8 and 45, no, we can't simplify that. So what if I open that? So I tried to simplify just like I did for number 2. That didn't work, so I'm going to move on to the next step. So I'm going to open that in 2 radicals. Square root of 8, square root of 45. Alright, so now I will have to simplify the square root of 8. So I'm going to do it right here off to the side. Square root of 8. I can rewrite a square root of 8 as a product as square root of 4 times square root of 2. The reason why I did that, square root of 4 is a perfect square. I can take the square root of 4 and get 2. Square root of 2, I can't simplify any further, so you leave that alone. So at this point, we have square root of 8 is the same thing as 2 square root of 2. So 2 square root of 2 right there. We're going to try to simplify square root of 45. I'm going to do it right here off to the side. Square root of 5, I can simplify as square root of 9, square root of 5. Square root of 9 is a perfect square. Square root of 9 equals 3. 3 square root of 5. 3 square root of 5 right there. Now, it's a big no-no. You cannot leave the square root of 5 in the denominator. You have to get rid of it. So we're going to rationalize the denominator by multiplying top and bottom, or numerator and denominator, by this guy right here. So when you multiply, you're going to multiply across. This guy doesn't multiply in because it's outside the square root, so you leave him alone. You're going to multiply 2 by 5. 2 times 5 is 10. Because it's under the square root, you leave that 10 under the square root. Multiply. So 3 is outside the square root. You leave 3 alone. And then you're going to multiply what's under the square root. I'm going to make a little arrow right there. 5 times 5 is 25. And you know square root of 25 equals 5. Square root of 25 equals 5. Right there. equals 5. 5 and 5 equals 25. They were both under the square root, so they remain under the square root. You take the square root of 25 and you get 5. Now you keep going because you can't leave your answer like that. So you get 2 square root of 10. 3 times 5 is 15. One last check. You have to check if you can simplify this fraction, 2 and 15. 2 and 15 do not simplify, so you don't have to do anything else, and you're good to go. This is your final answer. IXL EE3.